Let's see, what are we doing here? Unit 5, day 3, example number 1. Let's go. A little bit of a review what we did in the last class. So we're trying to figure out where in the unit circle do we have a tangency of positive root 3. Well, that's going to occur in quadrant 1 at pi over 3 radians. It's also going to occur over here in quadrant 3, where the only thing that's positive is tangent. Now we know a tangency of 3 belongs to the pi over 3 family. So as long as we know which family it belongs to and we know the denominator, you can find the numerator by looking in whichever quadrant we happen to be in, and in this case, quadrant 3. As long as you know the denominator, your numerator is 1 greater than that. So those are your two answers for example A. And I didn't lie, but I just forgot about something. Those are potentially our answers for example A. What we now need to remember is, well, what is the period of tangent? It's pi. It's not 2 pi, it's pi. And we need to read the directions. Solve and find the solutions over 1 period. Well, 1 period for tangent is pi. Pi over 3 is an answer because pi over 3 is less than pi. 4 pi over 3 is not an answer because it's greater than pi. It would take more than 1 period to accomplish 4 pi over 3 radians. Now, here's what we're going to do. We're going to do example B now, but you see how we have a 2 times theta? It's going to change our problem up. But the way that we would start this problem is exactly the same way that we'd start this problem. We would just pretend like it's just the same as this, disregard the 2. So we would still end up with the exact same answers, potentially pi over 3 and 4 pi over 3. What we have to do now is we have to find the new period, and we do that by looking at our B value. We learned this back in unit 4. Our B value is 2. Now, the formula that we learned last unit to find a new period was 2 pi over B, but that's not going to work here. The reason why is because tangent waves have a period of pi, not 2 pi. So we actually need to do pi over B, and our B value is 2. Therefore, our period here is pi over 2. Now, we're not done yet. Whatever you have in parentheses, once you find your radians, what you're supposed to do is you're supposed to take what you have in parentheses and set it equal to your radians. Now, they have 2 theta. I'm using 2x. I haven't really given myself a lot of room here, so let me rewrite this. 2x is equal to pi over 3. 2x is equal to 4 pi over 3. Now, in order to solve for x, I'm going to multiply both sides by the reciprocal. Leaving us with x equals pi times 1 over 3 times 2. Now let's do the same thing over here, multiply by the reciprocal. Four pi times 1, 3 times 2, which you could reduce to 2 pi over 3. So these answers, now that we set them equal to x, the number that was inside parentheses, these would be our potential answers. Pi over 6, 2 pi over 3. But it wants us to solve for 1 period. Pi over 6 is less than pi over 2, so that's an answer. 2 pi over 3 is greater than pi over 2, so that's not. Example C, sine of 2x is equal to -1 for the time being. Let's just pretend like there's nothing in those parentheses. Let's just figure out where in our unit circle is sine -1. And there it is right there, right where my pen is pointing. That location is 3 pi over 2 radians. Now we have one more step. We have to take into account what is inside those parentheses. Whatever's inside those parentheses, set it equal to your radians. Multiply by the reciprocal so that we can get x all by itself. 3 pi times 1 over 2 times 2. So 3 pi over 4, that's potentially our new answer. Let's solve for the new period to see if it is. Now we're dealing with a sine wave, so we are going to do 2 pi over b. Your b value is the number inside parentheses in front of the x, so 2 pi over 2 for a period of pi radians. 3 pi over 4 is less than pi, so that is an answer. Now what we're going to do is we're going to now look over here at this problem. It's exactly the same. See? Exactly the same. But here's the difference. Here we solved for one period from 0 to pi. Now they want us to solve from 0 to 2 pi. So what we're going to do is we're going to include our previous answer. And then in order to figure out what the other one is, we have to take 3 pi over 4 and add another period to it. We're going to add pi radians because that's the new period. 3 pi times 1 plus 4 times pi over 4 times 1. For a final answer of 7 pi over 4. So we have two answers for this one. Example D. Let's not worry about what's inside the parentheses yet. Let's just get rid of this square by taking the square root of both sides. The square root of 1 is 1. The square root of 4 is 2. Remember, we're not worried about what's in the parentheses yet. What we want to do is we want to figure out where in our unit circle is cosine positive 1/2 and where is it negative 1/2, meaning we're going to have 4 answers here. When cosine is 1/2, that belongs to the pi over 3 family. I'm running down 4 of them because, like I said, we're going to have 4 answers here. Quadrant 1, this is the answer. Quadrant 2, there's the answer. Quadrant 3 and quadrant 4. Okay, now we have to do the additional step. We do now need to take into account what's inside the parentheses. So we're supposed to set each of these equal to x over 2 and solve. I'm only going to set the first one equal to x over 2 because I think that you'll see why in just a moment. In order to solve for x here, we'd have to multiply both sides by 2 to get x equals 2 pi over 3. So this is our new answer. If you compare it to the original, we just multiplied the numerator by 2. 2 pi over 3. See? So that's what we have to do to these other ones. Just multiply the numerator times 2. Now, all 4 of these answers, they will be an answer for example D. The way that we know that those are going to be answers is because, well, we have to solve for the new period. So what we would have to do is we would have to take 2 pi over b. Our b value here is 1 over 2, which is the same thing as keep, change, flip 2 pi times 2, 4 pi. So that's the new period for this one. So like I said, all of these 1, 2, 3, 4, these are all answers for example D. Now, if you'll notice, this example here is the exact same problem, but instead of solving from 0 to 4 pi, they want you to solve from 0 to 2 pi. These two radians would fall in that region. These two would not. So these two answers are the only acceptable answers for that example right there. For example E, start by subtracting both sides by 2. Now they didn't put this in parentheses, but I'm gonna go ahead and do that just because I prefer it that way. Okay, let's divide both sides by root 3. Okay, now that we're left with nothing but our trig function and what's in parentheses, we want to go ahead and do our reciprocal here. So the reciprocal of secant is cosine, and the reciprocal of negative 2 over square root of 3 is negative square root of 3 over 2. Let's take a look at our unit circle. We need to figure out where is cosine negative root 3 over 2. That's going to occur in these two quadrants. Now, when cosine is root 3 over 2, that's the pi over 6 family. Here's the pattern for quadrant 2. Here's the pattern for quadrant 3. So 1 less the denominator, 1 greater than the denominator. Don't forget, we now have an additional step. So we have to take our answers here. I'm running out of room, so let me get another sheet of paper. Take your answers and now set them equal to what's inside the parentheses. We can solve for x by multiplying both sides by the reciprocal. Five pi times 1, 6 times 3. Over here, multiply by the reciprocal. Seven pi times 1 over 6 times 3. Those are your two answers. Okay, we're going to end our notes by crossing out example F and example B. If you would like to see those done at any point in time, let me know during class. I'd be more than happy to go over those with you. So let's end with example 2A. Looking at that last example here, while this does look like we can start factoring it, notice that we have two different trig functions. In order to factor it, we have to narrow it down to one trig function. Whenever we see sine squared there, I want you to think Pythagorean identity number 1 that we learned in our notes from Unit 5, Day 1. I'm going to write out that identity now. Now, what I want to do is I want to just get this equation down to where it's simply sine squared of x on the left side of the equal sign. In order to accomplish that, we have to move over cosine. Okay, I've done that. Sine squared of x, sine squared of x. So now we can do substitution. Since this is equal to that, I can substitute that for that. I'm going to start rewriting my equation now, beginning with 2. Open parentheses, but instead of sine squared of x, I'm going to substitute what its equivalent is. And then continuing on with the rest of the problem that I just underlined. We want to continue on by multiplying and distributing that 2 throughout the parentheses. So 2 times 1 minus 2 times cosine squared of x Now, if you look here and there, we have like terms that we can combine and narrow this problem down a little bit. And now I'm going to combine those like terms to get -1. Now we are about to the point where we can begin factoring, but your leading coefficient is negative. You don't want that. So let's divide everything by -1. We're going to do a little mental math here. If we divide everything by -1, then the signs are going to flip. Now what I'm going to do is I'm going to rewrite this trig trinomial in a manner that's more pleasing to the eye, something that we're more accustomed to. So rather than 2 cosine squared of x, let's do 2x squared minus 3x plus 1. And now we can begin factoring. Multiply the number in front with the number in back. We need the multiples of 2 that add to get -3. Now we can use substitution. There we could factor out an x. There we could factor out a -1. That's our first factor. Our next one would be 2x squared divided by x minus x divided by x. Now you set each of these equal to 0 and solve. If we set x equal to 0 or x minus 1 equal to 0 and solve, we get 1. If we set 2x minus 1 equal to 0 and solve, we get 1/2. And now just remember, these were trig functions, so write the word cosine in front of these x's. So where in our unit circle is cosine 1? There. That's at 0 radians. Where is cosine positive 1/2? That would be in quadrants 1 and 4. And when cosine is 1/2, that is the pi/3 family. That takes care of our quadrant 1 answer. That takes care of our quadrant 4 answer.